Hi, and welcome to the University of New Haven. I'm Dr. Chris Martinez. I'm professor and coordinator of the computer engineering program at the university. And I'm going to be your tour in this virtual open house that we have. So electrical and computer engineering is usually going to be found together at all universities. You likely see the term ECE in a number of different universities that you go to. We're unique here at the university in that we have an ECE and computer science department all round up into one. What this is going to provide you is just not an education in electrical engineering, an education in only computer engineering, but we are going to be highly tied to computer science as well. And what does all this lead you to? Well, you could kind of think of electrical and computer engineering and computer science as our department of technology, where everything that you deal with in everyday life that has any type of technology component was all made from our department. And electrical and computer engineering focuses on the hardware side, while computer science focuses a little on the software side. And because we are joining together, you're going to have a lot of courses in common, and you're going to be a more well-rounded engineer. So with electrical and computer engineering, we are going to go through a little bit about what it is, some of the fields that you can get into here. Well, what is electrical and computer engineering? Well, like I said, it's designing technology, and it's a lot of the hardware in our technology. You could think of electrical engineering being more focused on the analog and communication side of the hardware, while the computer engineering is really focused on the digital aspects, the programming aspects. So what are some common items you can say, this is what an electrical and computer engineering professional has created? Well, the design of smartphones is heavily electrical and computer engineering product. You have modems, you have Wi-Fi, you have software, you have an operating system, you have memory, a CPU. All of those are items that an electrical and computer engineering professional will create. We design robots. Here on this slide, you are seeing a humanoid-looking robot. Well, what parts of electrical and computer engineering are working on that? Well, you got the vision of the cameras, of how we're going to be able to detect objects. We have sensors to know if the ground is level or not. You have sensors to tell should the hand close tighter, looser. So there's a lot of work that's going into a robotic system. We help to design the internet, all the networking computer equipment you have, the Wi-Fi router in your home, all the networking switches and businesses, all of those were done by the ECE programs. And then the actual integrated chips, which might be your first thought of, oh, that's what a computer is, the actual physical chip that we create. Other items are more common that a lot of people think of when they hear the term electrical is the actual electric grid. So it is a lot of the EE professionals who design the grid of how we're going to deliver power from the power plant to your house, all the distributions that goes through it. We're really focused now on renewable energy. You'll see a lot of EE work into wind power, solar power, trying to blend a lot of these mixtures together. You also have a lot of satellite communication. The communication is a really good mix of electrical and computer. You have a lot of our communication now is all digital, but the actual transmission that hasn't come out is an analog signal. So we got to build all the antennas. We got to build the transmitters, the receivers, and that's going to take a lot of work from a lot of different areas. There's a lot of new stuff that's entering the field. We have the Internet of Things, which is a new up-and-coming area. Commercially, you've probably seen a lot of this in your own home, but not really connected with the term Internet of Things. We have Alexa, we have Alexa plugs that can turn on light switches. We have Ring doorbells that will tell you when somebody's at the door. We have Nest controllers that control the thermostat of your house. All of these are commercial types of Internet of Things. On the industry side, we're seeing Internet of Things being small little sensors that we can deploy in the field. It might be on a bridge to see what the weight is, the distribution of it. We might have sensors on the street, so we know when the cars are moving through to kind of control the traffic. We also see on this one slide the electric vehicles. This is taking a lot of work in electrical engineering and computer engineering. We have how do we charge these vehicles faster? How are we going to get the most power out of the batteries into these motors? We have a lot of these electric vehicles like Tesla, where they have a lot of computer support into it, where we're seeing, the Tesla car kind of being able to drive itself. Well, that is a lot of computer engineering that's going involved with that. In today's climate, we kind of see that besides just the technology, it's a lot of healthcare that electrical and computer engineering students can be involved in. We have a lot of implants that will go in, pacemakers. We have insulin pumps that get installed into people's body now. Well, that has to have some electrical properties into it. We need designers in order to do that. You see here in this other picture, we have a little test equipment that can test all the vitals of a patient. Well, that again needs to be a lot of electrical work to be done. We kind of spread the entire field of society. It's not like when you think of a civil engineer, you quickly think, oh, they build roads, they build bridges, they build how the buildings withstand, stress. When you can think of electrical, you think of computer, it's anything you really want and have a passion for, you'll be able to find a job working in that field. If you want to be in the music industry, there's going to need to be engineers who do all the sound mixing. All that equipment has to be built by somebody. You want to have a passion for cars. A lot of this is becoming autonomous. We're going to need a lot of electrical and computer engineering people in order to make that a reality. If you want to work in video games, again, it's going to be a lot of technology involved. Any aspect of life that you really have a passion for, you can take all of your knowledge that you're going to learn in this one major, and you'll be able to find a job that's going to be able to really take advantage of that. New areas that are up and coming that we're really focusing our curriculum on are data science. In the last 2 years, we launched a graduate degree in data science. We see artificial intelligence, machine learning, deep learning, all of this becoming not just buzzwords, but a lot of stuff that industry is actually looking for students to have the capabilities of working with. While we have graduate programs that are really focused on this, we're seeing how can we move a lot of that curriculum down to the undergrad level. So while you're here studying for the next 4 years, I wouldn't be surprised if you start seeing a lot of these courses being offered as electives that you can take. Items that will kind of form what the next area of technology is going to be moving to. Now, a lot of how you can measure our success here at the university is you really got to look at where our graduates go. What the success of our alumni is really is the success of our program. Here I have 2 local Connecticut companies that hire quite a bit of our engineers. We have where we're located in West Haven. If you go around 10 miles west, you get to the Lockheed Martin Sikorsky aircraft. If you go east around an hour, you end up with Electric Boat, which make a lot of the submarines for our nation. And in February, we had a Lockheed Martin Day here on campus, and the president of the company was talking and saying that if he was to look at all the engineers that they hire, all the employees Sikorsky has, they go around the country to every career fair. They'll visit the top engineering schools, they visit the top public schools in the nation. And if you look at who is employed by Sikorsky, the vast majority are UNH students. They hire a lot of our graduates, and a lot of them become very successful. The vice president for engineering is one of our mechanical engineering alumni. So you can see that our programs here can build a huge success rate in taking you and having you in a job that is, you can find satisfying, that it helps, people. And with these 2 examples of helicopters, Sikorsky is known for the Black Hawk helicopter, Electric Boat. They make every single submarine that we have. You are seeing some of the most highly technological, advanced machines. And a lot of our students, our graduates, are working to build those new radar systems, the new electronic jamming systems, how the engines can be more quiet for stealth technology. And a lot of that can move over to other fields, not just defense work. Other areas where our students have worked is in the energy sector. Here in Connecticut, Eversource hires a handful of our graduates every year. Con Edison for the New York side, the New Jersey side. We have big tech companies such as Microsoft and IBM, where a lot of our students go to. We have other defense work or aviation with Boeing and Pratt & Whitney, where we see students go, continuously every year too. We do have a lot of more local companies, which are not like the huge names that you may have heard of, but it has a lot of work that you probably have dealt with on your everyday life. In the bottom corner, you see a little logo for Kitchen Brains. And probably none of you have heard of what Kitchen Brain is, but you probably have dealt with Kitchen Brains technology and probably once a week or even more for teenagers out there, where Kitchen Brain makes all of the controllers that go into commercial kitchen equipment. So I always find it funny when students go and they internship at Kitchen Brains, when you kind of ask them when they come back, oh, what did they learn? They're like, the next time you go to KFC or you go to Burger King and you're gonna have your fries made or your fried chicken made, they're excited that I'm the person who made all those controllers for it. We have Viacom, which is a company from England, but they have a headquarters here in Connecticut, and they make all the video equipment for movie studios. They make, if you have any kind of professional grade video camera, Videocom has a lot of their technology in it. The JK and Aerospace and the Belkin Engineering, those are subcontractors to Sikorsky and Lockheed Martin. So we have a lot of different areas. We even have some bioengineering companies in Connecticut where a lot of our students can work in as well. So up on the screen, you're going to see a little bit of where our alumni are, what kind of jobs they have. Some of them I left a little testimonials. So hopefully you can read a little bit of this while I continue my presentation. So while these are up, I'm going to talk a little bit about what our programs here are, so you can get a feel of what it is that we offer. So we have a BS in electrical engineering, and then we have a BS in computer engineering. These are the standard undergrad degrees you'll find at every college in the nation. What we are excited for is this is the first year where freshmen are going to be allowed to sign up for not only committing to say, I want to do a bachelor's degree, but I also want to do a graduate's degree. Now, there's going to be some limitations to this. We're really going to look at your background, your SAT scores, your grades in high school. And if we find that you are going to be highly motivated, academically, you're strong enough to join these programs, you're going to get an invitation in order to get into one of these, what we're calling dual degree programs. Now, you'll start off in these degree programs. We'll monitor your academic progress. And as long as you're keeping up good and you're meeting all the requirements for a graduate program, you will automatically just keep rolling through. You'll earn your bachelor's degree, and then you'll also earn your graduate degree in a year and a half afterwards. Now, what's exciting is in the electrical and computer engineering fields, in order to kind of take advantage of these dual programs, we're not tying you just to one discipline. You're going to have a wide range of options that you can take. If you are a computer engineering student and you decide, I want to do one of these dual programs, it's not just undergrad and a graduate degree in computer engineering. We have a lot of different tracks that you can take. You can take a bachelor's of computer engineering and decide, I want to do a master's in electrical engineering. Or you can say, I want to do a master's in computer science. And in computer science, you can even choose a cybersecurity option, which is one of our highly competitive programs here. You can also choose to do, I want to do a graduate degree in data science, or I want to do it in biomedical engineering. you're going to have a wide range of options on where you want to lead into. When it comes to electrical engineering, you can do the exact same options. You could do a bachelor's of electrical with a master's of electrical, or a master's of data science, or a master's of bioengineering. We really want to give you that you have all the options and to really find what your passion is and to take you to the next step that you can leave here knowing that you're not just getting into a regular entry-level position, but you're going into a more medium sized job with all the extra background you have. Besides just the graduate programs, we also are going to have a lot of options for you to take your electives and kind of mill them into minors. Some of the most common minors a lot of our students takes is a minor in mathematics. And that's just because you do a lot of math as an engineer. And that really complements a lot of the advanced topics that go into engineering. We have students who have gone on to do minors in physics, sound recording and music, because a lot of those courses kind of transfer over. We also have students who have gone on to do more of like graphic design, because that comes in handy as an engineer, because you can really kind of build what the product is going to look like. So we really want to give you a lot of different options and not just focus you on just having just an undergrad degree. So here you'll see a lot of the different options that we have. I kind of went through most of these. Now, what is it that kind of makes us unique besides just these new dual degree programs that we have is this little diagram kind of shows you everything that we do that we feel makes us a little bit special. At the top part, you see that it is experiential based learning. Now that might be a new term to you, but what it kind of really comes down to is we want hands-on, real-world problems that you are working on. So besides our courses just being, you get a textbook, you go to class, you listen to a lecture, you know you got to study chapters 1, 2, and 3 for the next exam. We really want to break that mold. From your introduction to engineering all the way to your senior level course, we want you to have real hands-on work. Almost every single course you take that has an engineering prefix on top of it is going to have some type of hands-on project. Some of the projects are going to be building with real technology, real hardware, where for our circuits class, you're actually going to go and design circuits. When we go to courses like communication systems, you're going to you need to make a FM transmitter. Now, we're not going to make you physically build it, but you're going to use all the simulation tools that are actually used in companies. By the time you leave, not only are you going to have the knowledge of a lot of these different areas, you're also going to have familiarity with the hardware that is used, and you're going to have familiarity with all the software products that are used. A good example of how we build items is I teach a senior level course called System on Chip. And this is one of the more popular courses in that what this course is, it is solely focused on a semester-long project of making a video game system. At the beginning of the year, you start the first day, I give you a blank board. It's called an FPGA development kit. And it's really just a blank piece of silicon. And throughout the semester, we are going to build a 1980s Nintendo system. I give you a Nintendo controller. We'll figure out how the controller works. You design the hardware to get that controller to work. You design basic 2D graphic engines, and you'll get the graphics to work. You'll take all of this hardware, learn how to connect it in with a CPU. From that CPU, you'll actually design all your software to make that video game. These are ideas of different projects that we do where we just don't want you to learn from a textbook. That kind of leads down to the next item in this little list that we have, which is the Junior Design Lab, where once you hit that junior year, that spring semester, you've taken a vast majority of your engineering courses. And now it's time to see, can you take everything you learn and apply it to an actual high-level topic? Now, some of these items that we have you do in the course, are common items that we use commonly like every year, that we know exactly what components you need to use, a lot of mentoring to kind of get you along the process. Examples in the past has been we have done a little robotic car that has sensors that when we take it onto like a street simulation, it's able to look at traffic lights, know when it should start slowing down, when it's safe to go through the light because it's green, you know, when yellow is starting to pop up, what it needs to do, the car. We've had students work on creating controllers for solar panels that would tilt the panel, rotate the panel to really get the most benefit out of where the sun is at that moment in time. And a lot of these are items that we'll do at the junior design level. We have a mandatory internship / a research component, depending on which kind of track that you want to go down. If you're really involved in graduate school and that's you're going to be a focus on, we kind of say, okay, why don't you do a faculty mentored research project? If you really want to get out of the industry, we say, okay, why don't you work on an internship, get out working with real companies, build your networking capabilities, build your resume so that you can be successful. We have our senior design experience, which is a year-long project that happens. We have a fall course, we have a spring course, and you will build well, a lot of times we have companies come with ideas that they want to have explored. We have faculty that have some ideas from projects that they want to explore. Even some students come up with projects. In a little bit, I'll show you some pictures from our expo that we have. We kind of explain what some of these projects are kind of like. We are really unique in that a lot of engineering programs do not offer a study abroad experience. Here, we take pride in experiential education, not just being hands-on work, but really seeing a complete 360 view of who a student is. And a student can go out to our campus in Italy, and when they go out there, they come back and you really hear how they have changed, like their mindset. They're kind of out on their own, besides just living in a dorm in a different country, learning how to explore a country where even though a lot of Europeans speak English, you know, kind of get a little bit out of their comfort zone, and they really have a great and unique experience. And a lot of problems that engineering schools have is our curriculum is very tight. You can't really just have a student go off and take just humanities level courses. But what we found is we really want these students to have that experience, that along with just the students going to Italy, we'll also send one of our faculty members over there with them so that they are also learning how to speak Italian in a language course. They're learning about all the art and the history of Italy, but they're also learning the engineering topics that are not going to allow them to fall behind. And that's something, if you really have an interest in, it's something you should really take advantage of. And we also have a private school advantage where we have a lot of different resources. When it comes to tutoring, we have some of the top-notch tutoring services that are available. We'll give you tutors from our seniors and our juniors that have taken the courses. Those are BTAs that are inside our course. We have a Center for Learning Resources where we have professional tutors that the university provides. So we're going to have a lot of support mechanisms for you. Our faculty are very highly qualified. You can go onto the website, you can see our bios, get an idea of who we are. A lot of faculty, while we have a lot of full-time faculty, we do have to hire some adjunct faculty, but the adjunct faculty we hire, all of them work in industry, so they're able to take projects that they're working on at work and kind of tell students what it is that they are seeing. We can change our curriculum to kind of line up better with industry. And it's really a win-win situation for everybody. So here are some of the little pictures about our senior design. The senior design really is the culminating experience of being an engineer here at the university. So in here, every spring semester around the time of finals, every engineering student, whether electrical, mechanical, civil, they all get into our auditorium. And you can see here they all have posters where we have faculty, we have alumni, we have industry partners come out. They'll go to each little poster board here. They have the students give a little elevator talk, kind of tell what the project was. We have a competition that runs. A lot of the students are showing demos out of everything they have created. So here are some of the electrical and computer engineering projects that have happened in the past. Here, it's a little bit hard to see, but This students here were designing wireless charging for cell phones. So the different pads you see there are the different electronic pads that they have. They can attach some little sensor to the back of your phone. You lay the phone onto the pad, or charge it without having to plug it in. This project here was done by the lead company. This was an industry sponsored project. The lead company is a medical supplier. And what they had interest in was they needed a control system that could deliver correct dosage of medication through pumps into IV bags. And they needed to be able to switch IV bags, switch the medication that is coming through. And the students here in this project were able to develop a mechanism to automatically do all that pumping, controlling systems on their own. The job industry for the ECE majors is very good. A lot of technology is highly advancing. Like I said, the Internet of Things is taking up, all of this data science is taking up. For the nation in 2018, the median salary for entry level was $67,000. In the Northeast, you're usually going to see this quite a bit higher. Students usually are offered in the 70,000s, depending on the company. Some companies have even given $10,000, $15,000 signing bonuses. So it really is a great area for you to be involved in. Outside of just our academics, we have a lot of student activities. Here's a little list of items that we have that are clubs, honor societies. We really hope that when you come here, you're not just entirely focused on your, learning technical skills. We want you to learn some more soft skills of communication and leadership and team working. And these student activities are really great ways for you to be involved and to really grow who you are as an individual outside of just your academics. So that kind of concludes what this small little virtual tour is of who we are. If you have any additional questions, please feel free to contact me. You can send me an email. It is going to be cmartinez. It's CMARTINEZ@newhaven.edu. I really look forward to seeing you in the fall. And I think if there's one thing all of us as a professor, you as a student, and your parents are probably quickly looking forward to the fall. We really want to get this whole quarantine over with. So I really hope to see you in August.